Good morning, Devox. How are you today? Are you good? I'm Michał, and today I'm gonna talk about three things. First is BDD, then Groovy, and we'll end up with the Spock. And I'll try to focus how can we use Spock for BDD purposes as the BDD tool. All right, so let's begin. So here is the typical Apple product. Just one button, white lid, and it sells in the millions of copies all around the world. Then we have a typical Google product. One text field, one button, and the millions of users, the billions of dollars revenue every month. And here is the typical our product. Lots of buttons, mess, complexity, and so on, right? Do you recognize that? Is this how your application look like? Yes. Actually, my application that I work with is even worse because it has no GUI at all, and all the complexity is hidden, so even no one can manage the amount of the crap we have underneath. But on the other hand, this is not rocket science. We are not sending any rockets to the space. And my project, at least, is composed of lots of ifs, some decisions, some XML, and that's it. And we all know that picture, right? That it's not the technology problem that stops us delivering the things. It rather is the people problem, right? The communication problem, communication issues. So how can we avoid that? And looks like the only problem is to understand the problem. There are no more problems in the software development. We need to understand what we are trying to do and then do the things, not the other way around. And it's all about creating software that matters. Software that realizes these high-level business goals. And the business people are really strange guys that are floating somewhere between the clouds and sky, and we really struggle to understand them. What are the real goals of the software that they are trying to deliver? And the most basic question would be, how can we guarantee that our software realizes these high-level business goals? And one could say by testing, right? Do we have any students here? No students? Not at one, right? I was on that level when I thought that compiling is enough. Yeah? It's enough to guarantee that my software will work. But we are all responsible guys, and we know that testing, unit testing is really important. Yeah? You all do unit testing, otherwise you wouldn't be on that conference. But that's only the first stage. That's the basic verification that what we coded actually works. The next level is that we verify the software before it is written. We follow the test-first approach, where we have the verification before we write the code, and the code is created just to fulfill this specification that we create at the beginning. And then we have TDD, where not only the code is driven by tests, but also design is driven by our tests. So it's test-driven development, where we write the test, then we write the implementation and refactor. We do heavy refactoring, which actually is design phase, where our design emerges. Right. So let's talk about history a bit. So it all began with SUnit. Back in 1999, Kent Beck, with his team, they were following these TDD principles, and they used SUnit for Smalltalk, the first unit testing framework with from this XUnit family. And then, suddenly, all that happened. All languages that reached the critical mass had their own XUnit frameworks. So when Java became mainstream language, at least in financial industry, we all started to use JUnit, and all the languages like PHP, CPP, C#, they have their own XUnits, right? But if you are just unit testing, you are not doing it good. Actually, unit in JUnit name is a bad thing, because test-driven development is not about unit testing. Test-driven development is about testing. And a few years ago, Dan North had to come to us and say, come on, guys. In order to realize these business goals, unit testing is definitely not enough. You need to test the software, test in proper way. And in fact, he was not saying anything different than test-driven development. He was defending test-driven development, but done in the right way. So we have Dan North, and he even created new language for our acceptance testing. It's called Gherkin. And what Dan North was saying, that specifications should be understandable to developers, which is quite easy. We are smart guys. We are really smart guys, and we usually understand what the business are talking about. The biggest issue is here. The specification should be understandable to business. So we need to minimize this gap between us and the business guys in order to have the shared understanding of the system. Then they should be unambiguous and for sure automated and run frequently, because we want our software to behave in the correct way all the time, not only once. So we have this Gherkin language, which, if you are a traveler, you'll know the Gherkin from the London. And if you rather like Polish climates, you'll know Gherkin as this thing, right? And in Gherkin, we have just three main keywords. The given one, where we set up the state of the word before our test. Then we have when keyword, where our behavior happens, when the things happen, when the stimulus happens to our test. And then the then phase, where we check our expected results, where we do our assertions, when we verify if the software works, basically. All right. So here it is, this JBehave framework. It is plain text file with the specification of what is expected, right? And I gave a sample of just a calculator, very simple one, when we want to add the things and check the result. And the very important thing would be narrative. It's a thing that we didn't have at the beginning in our project, and we found it really helpful, because it's not only about examples. They're really helpful. If you ask the business, give me the test, they wouldn't say anything. They would run away. But if you ask them, give me example, they can give examples straight away. So examples are really good, but we need also the context. Why we introduced such feature, why we need this calculator, right? OK, whenever we have this plain text file, we need to execute it. And we execute it in Java by creating this glue code, where we take the steps by annotations, given when done, and then we match the lines from this plain text file to the proper method invocations. And that's it. We do normal assertions, as in JUnit. Actually, JBehave is just a wrapper to the JUnit. Quite thin wrapper. Not many new things, except that we drive our test not from Java code, but from the story files, plain text files. And we need to configure it. And that's the bad thing of JBehave, right? At least it's just once. So that's good, that we just need to once configure JBehave, and then we can go. We are ready to go. All right. So we used JBehave a lot in my project. And I've never met a person who was really happy. I've never met a person who was happy that today, okay, I'm gonna write JBehave test. And what are the reasons that people really didn't enjoy at all writing this kind of stuff? First of all, we have twice as much files to maintain. We have this glue code, this horrible, nasty glue code that needs to connect these two files. So whenever you like to modify anything in a test, you need to open the two files in split view and then move between. Not very efficient way of working. Then the developers are accustomed to press Shift F6 when they want to change the name, when to refactor the stuff. Where actually in the story files it doesn't work at all. Yeah, so we need to manually change so basic things like wording. Yeah, we need to modify the two files manually to change the wording. And if we want to change the wording in multiple files, oh, it's even worse. Then there is so huge overhead of this JBehave specification that it is rather for system level. If you are using JBehave on unit level, you are not definitely doing it good, right? It takes a lot of time and effort to prepare any story. So you would have 0% code coverage if you used JBehave on unit level. And then the story files are really dull. Probably you don't see what's there, and that's on purpose, yeah, because they blur. Whenever we have the more text in the story files, this is not readable at all. Business people wouldn't like to read that kind of mess. And then we have this parameter converter. So whenever we use any constants, any enums in our JBehave test, we need to manually convert them to the proper Java types. So the type safety comes with this work for monkeys. And remember, you can be replaced by a trained monkey anytime. So do you want to be such a person, or you want to create the things that are really challenging? And JBehave requires from us creating a lot of these kind of converters. And this is the example of how we convert true-false values from these story files. It's a lot of boilerplate code, just to do the simplest thing. All right, and then these steps are matched with these annotations using regular expressions. So whenever we have this parameterization in the story file, it's replaced with .star, the greedy regular expression. So imagine how many hidden things, hidden bugs can be in these story files when we use greedy match operator, and we try to match the steps with the proper implementations. So you need to have this regexp matcher all the time running whenever you work with JBehave. Good. And then, at least in my project, it occurred that only developers write story files. So the idea was that everyone would be involved. This would be collaborative approach. But it was so boring, so dull, that only developers were required to do that, and no one else was willing. And all of them were really disliking it. And the worst thing was that business people wasn't reading these story files at all. So it occurred that tool designed for non-developers was used only by developers. So something is clearly wrong. We are misusing the software. So you may end up with the thought that BDD tools are mostly total crap. And I agree. I think that whenever the JBehave is used only by developers, it's just a crap. It doesn't bring any value for the effort. Good. So what can we do with that? Do you have any ideas? Can we do any better? On the other hand, we want this software that realizes the goals. We want the pure specification of our product. So one could say that we can just use JUnit, right? It's the code that doesn't lie. Developers can read and understand the code, so why not use JUnit for our acceptance high-level testing? And one sample could be this one. Yeah, we can write in comments, given when then sections, and then write the code underneath. It's just the different structure, bit boilerplate, but at the end, it's the same. And if we don't like comments, the good code shouldn't have comments at all, we can name the methods in the proper way. We can start method names with given, when, then, a bit of camel case, but we are developers, we are really proficient in reading camel case, much more than normal people. So here is the test. I hope you can see it well. It's really nice test in BDD way. So it's Parametrize Test, and what this thing verify is that our vending machine accepts the bills. So we parameterize the test by putting $2 at one test, and then $5 and $10, and what we do is we are asserting that the credit in our machine is really according to the values of the bills. So look how great these parameters work. We just we return the collection of the arrays of objects, then we create two-dimensional array of objects, then three-dimensional array of bills. Then, because we like fancy tools, we create immutable list of that stuff and return that. Then we have nice final variables. Then we do great assertion because it's used with hamcrest. Yeah? Who have used hamcrest? Can I see anyone? No one uses. Oh, a few hands. That's great. Yeah. So we are checking in really readable way that our machine returned the proper amount. So is it anything wrong with me right now? Right. So this is nasty, horrible thing. Definitely we don't like to have such tests because they are not readable at all. Yeah? They are really polluted. It's just a noise. It's a pure noise, and how much of business content is in that test? Just this. Yeah? If we insert $2, we have $2 credit. If we insert $5 and $10, then we have just $15 credit, nothing more. So we drowned in the lot of mess, boilerplate, and it's not possible to extract any business knowledge without the proper reasoning about that test. All right, and to make things worse, every JUnit test is sad. It is really sad, yeah, especially if you use hamcrest matchers. So what can we do about it? So we already see that JUnit is usually a jungle, the jungle that we want to avoid, definitely. We don't want to go that way. And we already spoke that JBehave has a lot of disadvantages, huge overhead, not much benefits for our effort. Is there anything else that we can do? And from the title of this presentation, you may already know that the Groovy could be helpful, right? The Groovy language. Java is really old school language. It doesn't have all the features that would be really useful in the testing. So let me introduce the Groovy. And how many of you know Groovy already? Half of the room, that's great. So I'll just rush through these features of Groovy. So first of all, it's dynamic language. And some people, when they hear it's dynamic, they run away. They say, oh, no, this is dynamic language. I won't be using that at all. I love static typing. I love Java, and nothing else can replace it. But actually, the Groovy is statically type checked and compiled if needed. So whenever you want this safety, you can enable it, and there are no problems with that at all. And In fact, the Groovy is optionally and strong type language. You may ask, Groovy strong type? Am I right? But there is a distinction between what does it mean that language is strongly typed and what does it mean that it is statically typed. And Java has both features, right? It's both strongly and statically typed. So we cannot do things like division of integer by string. It just doesn't compile. Then we have C++, which is statically typed. We have verification during compilation phase, but it's not strongly typed. So we can cast the string to some pointer and then do the division. There are no problems at all. So this prints out just 0. Yeah, it works. There is no such type safety that string is a string and cannot be changed. And then we have JavaScript, where everything is possible. So do you have any idea what does it print? Any guesses? 0, I hear 0. Actually, it prints half, 0.5. JavaScript has no problem with casting string to the integer and doing the division. So imagine how many bugs could we have. And if we divided 1 by some letter, we would get a none, not a number. So very unpredictable results. And then we have Groovy, where by default, it is dynamically typed. So it compiles, such code compiles that we can divide the integer by string. But the IntelliJ would warn us. Oh, you are about to do a really strange thing. Are you stupid? Or something, or maybe you do it on purpose because you are not an idiot and you know that this would fail, but maybe you are doing some magic, so I would allow you because you may have some purpose in doing that, but I'll just warn you. So whenever you ignore that warning, it's your fault. But if you really do not trust the people that they will be checking warnings, you can annotate your class, your method by type checked, and then it behaves exactly the same as Java. It just doesn't compile. We cannot run this program at all. So you see, it's marked red. All right, so the first myth is defended. Yeah? Groovy is very flexible. It's optionally typed. We can adjust our typing to our needs. And then Groovy is created to work with Java. So if you don't know Groovy yet, after this talk you'll be a Groovy developer, because the first thing to know is that almost every Java code can be converted to the Groovy code without any additional effort. You just change the extension from Java to Groovy and you have valid Groovy code. So it has very flat learning curve. You can start today with the Groovy and you can learn the Groovy things, the Groovism afterwards, step by step. You don't need to master all the Groovy goodness at the beginning. You can do that gradually. And then we have multiple features of the Groovy language that it has over the Java. So we have the public by default. How many times you type the public, especially unit tests? Public void, public void, public void. Hundreds, thousands of times without thinking why this public is needed. So that's why in the Groovy they decided that the public is the most used visibility modifier, so why not make it default one? Then we have really powerful switch. The getters and setters are generated for us. We don't need to type them manually. Then we have the Groovy truth. And we can even customize what does it mean that something evaluates to the true or false. We have fancy operators like Elvis operator, spaceship operator to make our code even more concise and readable. Then we have operator overloading whenever it's needed. So have you ever tried to add big integers in Java? Is it nice? Is it easy to do? With the Groovy, it's just a plus. Yeah? In Java, it's much, much harder, not intuitive. Then we have optional return. So whenever you write the statement at the end of the closure of method, it just returns it. Also, it assumes you are not an idiot. If you put something at the end, you want to return it whenever the type is different than void. And we have really nice native syntax for lists and maps. This is one of the most requested features for Java. give me the list and maps, literals, and it's really useful in testing. You will create a lot of such stuff for the test purposes. So having that could be really nice, and also this notation is understandable for the business guys. It's just natural way of representing list of things or a map of the things. Then the math is precise in Groovy. So do you know how much it is in Java? 1 minus 0.9. Is it intuitive? Is the answer intuitive? Any guesses? It's just 0.0.9.9.9.9.9, and it ends somewhere with 8, right? Then 3 divided by 2 in Java would be just 1. What the business guys, what the non-technical people would say to maths that it's not intuitive at all. And while Groovy uses big decimal underneath, and it gives just intuitive answers to the maths question. On the other hand, this is the typical problem with the performance. So many people will say, oh, I won't use Groovy because it's slow. And it's slow because it uses by default these big integers, which are big decimals, which are really slow. So if you don't need this preciseness and you want the speed, you need to add the D suffix to indicate I want doubles, which are fast. I don't want precise math this time. And moreover, primitives don't exist at all. So everything is an object, which is, of course, more object orientation than we have in Java. So we can write one.class, then the dot simple name, and we have just integer. All right. Then Groovy says that if you want to use this punctuation, it's perfectly fine. But usually that's a clutter, that's a mess, and we allow you to get rid of all the semicolons, all the parentheses whenever the parameters are provided to the method, and we can remove all the dots when changing method calls. And this is really powerful, the feature of Groovy. So it occurs that having these features, we can create really readable sentences in the Groovy language, the sentences that would have meaning in English, and then they would be readable both for non-technical and technical people. So one example could be that invocation from Java. This is also valid Groovy code, but thanks to the Groovy optional syntax, we can rewrite it using that. So we have method order with parameter, then another method chained with 2 parameters, another method, and 1 additional parameter. Readable, so that's just the syntax, but huge difference in readability. Another example. We can leverage the named parameters of the Groovy, so we can check that Groovy is readable in a very readable way. And we can also do things like that. So I speak to Devox, Groovy is awesome, right? It has the proper interpunction, and we are just passing to the method speak to whom I'm speaking and to whom I'm saying, just as in English sentence. All right, and on top of Groovy, the Spock was built. And the Spock is the testing framework. Spock is not a unit testing framework. It doesn't have this nasty unit in the name. It's just testing framework for any JVM application. So you can test Groovy, Java, it's perfectly fine, and even other if you really want. So first of all, do you use Spock? How many of you? Not that much. Probably you wouldn't be on this talk if you knew the Spock already. So I'll just briefly introduce you to the Spock, especially in the BDD context. But first of all, let's talk what does Spock mean. And the author, Peter Niederwieser, says that it's just connection of the spec and mock words. And apparently it has nothing to this guy, so forget you've seen it. All right, then first thing that Spock does is redefinition of the words we use. So we do not talk about system under test, the classical suit. We just we rather talk about system under spec, system under specification, the things that we want to specify. Then Spock, as it's built on top of the Groovy, it can use all the Groovy features. We have them ready to be used. It's really easy to learn. It's same as Groovy. You can follow the very Java approach at the beginning, and then step by step learn the features of the Spock. It's based on JUnit, so if you have already JUnit tests running in your IDE or continuous integration, the Spock will work too. No additional configuration needed. These are just compiled to the very similar bytecode to the JUnit tests, and they can be just run. Then we don't have any assertion API. So someone could say, hey, what about my Hamcrest matches? What about my assert_j? What about my fast assertion? Can we live without them? And apparently, yes. So these frameworks were made to fill this gap in Java where we didn't have the proper ways of checking the things, while in Groovy it can be done just by operators, nothing else needed. No these assert equals anymore. Yeah? Do you like it already? All right. Then we have mocking API. So as I said, it's testing framework, so it can be used also on unit level. And if you gonna test on unit level, you will need mocks, because the unit level tests needs to be fast. They need to run in a couple minutes maximum. So you need to mock out the things that you don't like to use on this level that would be required to achieve the fast performance. Then we don't have these annotations on every method. The test annotation is not needed anymore. Just every test method is assumed to be feature method by default. So we don't have this assertion API, but we have really readable the results. So whenever our assertion fail, we have the feature called power assert. So it displays us exactly what went wrong. So even in my project, we used assert_j, right? The fancy library for assertion. And a couple of times I met tests on failing on the continuous integration with the message. 7 was not 8. Yeah? And that was everything that assert_j could provide us. When we were asserting on the integers, we don't have any context. While Groovy takes an entire line that failed and shows exactly what was the context. Why 3 was not 2? Okay, 3 was not 2 because you took the max out of 1 and 3, and this in result is 3, and you wanted to combine it with the 2, and the result was false because 3 is not equal to false. Yeah? So even without these fancy libraries, we have much better assertion information, what went wrong. And the guys from Groovy liked this power assertion so much that they ported it back to the Groovy. So we don't even need to introduce the Spock dependency. You can just use that feature in the pure Groovy language. Then, as we have this optional syntax, we don't have so much boilerplate. We can focus much more on specifying behavior and on our domain language. So Spock is just a testing language. It has really similar, it's actually the same syntax as Groovy. Spock is valid Groovy code. It has a bit different semantics than Groovy code. So effectively, it's just new testing language that is well suited for all test activities on every level, apparently. So we can use Spock to replace all the testing frameworks that you use on different levels, all the integration, unit, component, system, acceptance tests. We can do test first, test last, BDD, TDD with Spock. It's all good for that purposes. Then let's go to the examples, how we can create our first specification. So it's just by creating class that extends specification and by putting any name that we like that is valid class name to indicate the name. Then the feature methods. And feature method is just a name for test method in Spock. And you can put any name that is Unicode string as a scenario name. And as we are really good at reading camel case, the other people are probably not, right? So we can really leverage the thing that in Groovy, the method name doesn't need to be like this valid identifier. It can be just any string, which enables us to do the proper casing, proper spacing. It's just we can read like sentences, what we are testing in that scenario. All right, and now question for you. Does it compile? So it's a Java code, as you see. And do you have an idea if we press Ctrl-Shift F10 on that class, will it run? Any guesses? Is there anything wrong with this code? No means it would run or it wouldn't. All right, so here is the hint from IntelliJ. What does it say? Unused label. And afterwards, it's just a comment. So it's quite forgotten Java feature, and as it's Java, it's also Groovy feature, that we have labels that are indicated by the name and the colon. And they describe the section in our Spock test. So the guys from Spock used that very uncommon Java feature to create section of the test. So we have the given label, when label, then, and where. And they correspond to this Gherkin language, while where are just parameterization, optional parameterization to our test. Or if you are just creating one-liner test, very fast one, we can write expect, and afterwards the things will be asserted. Because this then and expect are really powerful labels because they indicate that everything that goes after them will be checked against Groovy truth. So whenever the result would be true, assertion passes. Whenever the result is false, then assertion fails. And we have data-driven testing. So you remember that sample from JUnit? How horrible it was just to write the simplest data-driven test when we wanted to parameterize it. In Spock, we just create tables. And this is really cool feature. It's hyper cool feature of Spock framework. We use overloaded binary OR operator just to create all the samples, and each row of the table would be executed as another set of parameters. And even if it would fail, as we see this maximum of 4 and 7 is not 8, we get the precise response. So we know that this scenario and that one passed, but the middle one, it's just not true, and we have the exact context what went wrong. So it's almost great. So we know that out of 3 checks to the maximum of 2 numbers to passed, and the third one is not correct, but it says just 0, 1, 2, it's not readable what we actually wanted to check. And what we can do is unrolling. So we can parameterize our feature method names. So to give the context what exactly we wanted to test in that one. So we wanted to check that maximum of 2 and 3 is 3. And it passed, while the other one didn't. And it is done by hash and just the parameter name. It's the header of this table. Very easy to use. Annotation unroll, hashes, and parameter names. I really love it. That's the power of the Groovy, and the power of AST transformation that is underneath. Yeah, great tools. We should use them if they are on the market. And then, as I said, you'll be using mocking, because we want to replace all testing activities with the Spock. And let's quickly go for the mocking. So We can define the mocks. Finally, we can distinguish between mock and stub. We can record them. And as you see, it's all based on operators. We don't have any additional syntax even for the things like mocks. So if you're using Mockito, there are a lot of methods names that need to learn. Entire API. We have two APIs, one for BDD tests, one for normal tests. While in Spock, we have just one API that is based on the operators. Nothing much to learn. So we can check the cardinality of the invocations. We can check what methods were invoked, even using regular expression as a method name. That's not the thing that I recommend to do, but shows you the power of the Groovy. So the method name can be even regular expression here. We can say that no interactions were made. We can say that no more interactions. So 0 times nothing was invoked. So this operator is quite similar to the Scala one. It means just anything, whatever. And then we have argument constraints. So we can say that any single argument works, any argument list. We can say something is not null, something was string. Just a Groovy syntax for entire mocking API. No more matchers needed. Good. So let's move more into the BDD stuff, the things that would be needed to collaborate with the business guys. So first of all, these titles that I introduced, they still need to be the valid Java-like class name. This is camel case, not the thing that we want to have as our specification name. So we can provide the annotation title and provide them more readable name for every specification. Then we can have subject. Subject as the thing that we'll be testing. It's our system under specification. Very nice annotation to distinguish what we are actually testing. And probably if you are having this subject, you won't mock it. It's the thing that you won't test. Very common mistake at the beginning. You are so enthusiastic about Mockito that you mock everything, even the class that you are testing. Right. Then narrative. And this is this context of the test that I was talking about. Really important thing that tells us what was the reasoning, why we need that feature. Usually it's just user story format. When we provide the goal, the business goal, who wants that, and what we want to create. And this uses really great Groovy feature that I really like in Java, which are multi-line strings. So we can begin with 3 apostrophes, and then we can write whatever amount of lines we need to provide the context. And it's not comment anymore, it's just a code. Yeah? So we have access it during runtime to this annotation. We can generate reports afterwards and so on. It has really unified format of the narrative. Okay, and then we have 2 additional annotations that we can use. First is issue, that we can connect if specification or feature method to some issue tracking system. And then we have annotation like C, additional links that would give us traceability to the things that we are testing. And the thing that I really like in JUnit, because it's told that we should follow this test-driven development, yeah? And you are not always ready to provide the implementation and the test at once. On the other hand, we don't want our CA broken. So whenever we start with a test and it's not yet implemented, what can we do? We can either leave it on the disk, which is against the continuous integration principle where we should commit every day, all the time. Another thing is that we can like commit and break CI. And Groovy and Spock has really nice annotation, not yet implemented. So we are saying this should fail. And whenever this will pass, the test, the things inside will pass, the test would fail, indicating you implemented that thing and you should remove that annotation. So it's really convenient way of doing this TDD, especially on higher levels when the loops take a bit more time than a couple of minutes. Good. then we have failure conditions. And so when we're doing TDD, we are so focused on the positive scenarios. We are running with our implementation, with the positive cases that drive our implementation, but we usually forget about the failure conditions, which are really important. We want to check our software not only in rainy day scenarios, but also not only sunny day, but also rainy day scenarios, right? So we can, of course, use expect exception in JUnit rule, which is really horrible. I don't like it at all. We can use catch exception library, which is a bit better, but Spock has it like by default. We just say thrown and the exception that we expect from that test. We don't even need to put .class like we need in Java. The class are first class citizens in Groovy. So it's a simplification. And this is just a code, right? As you see, this is code that is understandable for developers. But what if we really need this JBehave-ish specification, JBehave-ish textual descriptions of the things that we do? So the Spock goes with the textual descriptions for every case. We can put just after given, when, then, plain English explanation what this step is about. And underneath goes the code. So it has really big advantage over JBehave because we have all that joined in. We have all that in one file, and we don't need to split between the two. We have steps and implementation just underneath. Much easier to work with. And then, whenever we have these steps, we can extract them. So if we really need that report to collaborate, to be reviewed by the business, to be easily be grasped by new joiners who don't understand these features, we can generate the reports. And there are two projects that can be really customized to your needs. They can generate HTML reports out of these textual descriptions. They support example tables, and even we can generate the markdown. We can provide the template, so whenever you like to publish it on GitHub pages or whatever, markdown can be generated. If you want PDF documents, ASCII-doc can help us. So we can customize these reports from the Spock in whatever way, and it's like JBehave. We just generate the things from the test. Not necessarily we need to write them in the plain text. We can have all that joined in. And here is the next level, I would say. The next level, because if we have mainly developers or technical people working on software, we don't need this business collaboration, which some people say it's just rubbish. Yeah? We want just readable things for us technical people. So we can write the code in Groovy language that is just readable. So probably even person that is not really deep into technical stuff will understand what these tests do. And it's taken from my domain that I work every day, transaction reporting in the bank. So it just creates a message of type new. If our system receives that message, the system generates the report, and reports event type is equal to new. Yeah? It's perfectly valid Groovy code that reads almost like sentences. And probably don't even need these textual descriptions to really understand what is happening underneath. And here is even next level, that we found that our testing for this system is quite simple. So we noticed that the patterns, that message is being prepared and message is being sent and then received, report is received, and we are checking some things, so the report really repeats many times. So we invested a bit and created our own domain-specific language. So this is all Groovy code. Groovy code with the Spock framework capabilities that says that given the message is sent and the report is generated. And You might ask, come on, is this code or is this plain English? And apparently, as we have this optional syntax, given is just a method, new is parameter, then trade is method, and message is parameter. Then same goes to here. So here are the parameters and the methods chained. So we have this chaining going on here, which can create as the outcome testing language of our system. It's domain-specific language for our system, specifically suited for our testing purposes, and we don't require this JBehave textual description because they would look exactly the same. So instead of creating sentences and then glue code, we have just one place, no translation at all. So in real life, it looks like that. In IntelliJ with code coloring, with refactoring, so we really could press Shift F6 to change the name. If we wanted just a slight reward, one key press, and every test in our system was refactored. We had code analysis to detect any problems. And it was a lot more fun to prepare them. And actually, developers started to like this kind of testing. In comparison to JBehave, where they were really disappointed, now they had a fun with the Groovy. And actually, can you imagine how fun it was to write JBehave test with code completion? So we were just pressing Control space, and the code completion for our Gherkin language, for our domain-specific language, was just filling in because we have the tape safety, and the IDE really knew what are the possible options. Does it look good? Yeah, all right. And whenever we had this documentation written with nice title, narrative, and feature methods, it was still not ready to be shown. And in that case, really needed to work together with non-technical people on this specification because they wanted to learn what this system exactly does. And we couldn't lie them. The system was really crucial in the bank, and they wanted exact specification with the proofs that the system behaves like that. So from that Spock test, we generated the reports. In this case, it's Confluence. We just paired for a half a day, and then created converter from the Spock test to Confluence Markdown. Very easy, very beneficial, because in a couple of hours we created generator for these Confluence pages, which had really nice formatting, syntax highlighting, and so on. And actually, the business people, non-technical people, are really quite simple. So they like colors, they like formatting. And when they saw that, they were really happy. Yeah? Really happy, and they started reading that. They started verifying. We started working on that together. So even a few months afterwards, they were referring to this document and saying, okay, this was really useful things, compared to this JBehave, who we really tried to give them it to the review, to work, but they totally rejected. They were not interested at all in JBehave plain text descriptions, while this was really the place to begin the collaboration. So, a couple of things, the final thoughts. First would be, do not let intent to be lost in translation. So whenever you can minimize the amount of layers you have between your specification and the execution of that specification, it's better. Then you can create your own DSLs. You can do that in Java, but in Groovy it's much easier. So do not be scared that DSL is something that needs to be prepared from outside, and it's really hard to be created. Just a bit of code in Groovy, very easy, and you can have your own testing language of your application. Then it's totally understandable that this kind of Spock specification won't be created by the business. So that's a drawback. We won't give them IntelliJ and the code. Even if it has code completion, they wouldn't understand the complexity of the things that needs to be done. Actually, there are certain order of the things that needs to be run, verified, and so on. So we end up with the specification that still needs to be written by devs, but they really like it. And actually, they create it, but it's shared among all the guys. And then just remember that we have great tools, and we can leverage whatever is good in there. And most importantly, do not forget that this is the testing tool that you have, the best testing tool, your brain. And that's about it. So thanks a lot. Do we have time for questions? We have 5 minutes, I believe. Sure? Sorry, can you repeat? Ruby. You ask about Groovy. Under embedder. Debugger. Oh, debugging. Yeah. Sure, you can do that. It's a bit harder in Java, so it's, of course, a drawback because it has these expando classes underneath, this dynamic translation. But IntelliJ helps and filters out this unnecessary stuff. Normal breaks help, so we can jump between the code. And actually, we used debugger a couple of times, and we used all the possibilities that we had in Java. It just requires a bit more knowledge. So that's why this guy needs to be technical, because from time to time, we need to debug even our specifications to see what is going underneath. And that indeed needs more skill than in Java, but it's perfectly possible.
Is it possible to integrate the Spring stuff, for example, with Spock?
Sure. There are Spring extensions. So the question was about, is it possible to integrate Spring and Spock? And it's not by default, not coming by default, but there is support for that. So we can use that for integration testing of our Spring code. So we have such Spock tests in my project. I know the guys struggle a bit. It's not that straightforward. There are some additional problems. So some problems are gone, but a couple new ones. But actually, we have quite a lot of such tests, and they're working, running. So it's possible. OK, do we have any more questions? Yes? Mm-hmm. Right. So the question is, what tool for writing Groovy and Spock code I would recommend? And definitely I would recommend IntelliJ. And it doesn't need to be this enterprise paid edition. The basic community edition is perfectly fine. All the refactorings usually work correctly. In fact, the support is a bit worse than for Java. So because the Groovy has so many features that there's so much more possibilities occur, so we don't have such confidence that every factoring possible would work in every structure of the code. But indeed, IntelliJ has much better support for Groovy. And while creating such specification that I was showing, we didn't have any major problems with that. So don't need to pay anything. Just install IntelliJ Community Edition, and you should be ready to go. OK, I think that's it. Thanks a lot, and have a nice day.